Hello, and thank you for joining us. Thanks for the opportunity to be with you today. My name is Pablo. I work with the Red Cross Red Crescent Climate Center. And today we're going to share with you the first module of the Red Cross Red Crescent Climate Training Kit. This is about climate change. What are the science pieces of information that we have, that we know, and what are the impacts of climate change that matter to us in the humanitarian sector. In this module, we're going to learn first, why is the climate changing? Then what are the impacts of climate change? And finally, what does it mean for the humanitarian sector? Here we see a slide with a photo of drier land than you want. We know that climate change is manifesting itself around the world in many different ways. In some cases, it's drier than you want. In other places, it's much more water than you want. It can be wetter, it can be hotter, it can be strange extreme events such as forest fires. We do see across the world people reporting unusual things happening. Changing patterns in rainfall, in temperature, in winds, in currents. And this relates to what in science we are calling climate change. People report different observed behavior of nature and therefore new needs. In this photo we see a gentleman from Orissa in India. Here are some of the things he actually said. More floods, worse floods. Rains are no longer normal, no longer what they used to be. It's hard for farmers to know when to plant. The fields get eaten away by the sea. The sea is advancing over land. And what he says is, so our children have to move away. This is one example of people thinking of how to adapt to a changing condition that is dangerous, that is not positive. Now, migration is an extreme form of adaptation. In this module, we hope we can help you and your Red Cross and Red Crescent colleagues to understand what is going on and what can be done in anticipation of the changes so that the shocks are not so dramatic. And hopefully we can keep people having a good life in a place that they're familiar with, even if the climate becomes more and more unfamiliar. What people report is very often matched by what science tells us. The observations from the scientific community, from instruments, from measurement devices, from satellite images, from radar, from thermometers, from wind speed, from pluviometers that measure rain, all over the world are telling us that the problems that are being seen are not just local. They seem to be of a global nature. So, for example, in these two photos, we see how this glacier in Peru was in 1978, and then after a few years, only 20-something years, how massively the mass of ice has shrunk, has reduced. There's many things at play here. There are changes in temperature. As a result, if the temperature was above freezing, the ice becomes a little bit more prone to melting and vanishing and going down to the river. There's also changing in how precipitation comes from the sky. Maybe there used to be more snow, and now there is less snow and more rain, so the glacier doesn't grow, doesn't feed from what comes from the sky. It is important for us, as we learn more about this issue, to become familiar with the distinction between two related but different concepts, weather and climate. Weather relates to what is happening in the short term. Today, how should I walk out my home to go to work? Should I bring an umbrella or not? Should I bring a big warm sweater or just go out in a t-shirt? That change on a day-to-day basis is what we refer to the weather. If you don't like the weather, usually you wait a few days and it's likely to change. Now with climate, We're thinking of more long-term trends. If I were to travel to another country, if I'm going to Nairobi next week, what should I expect? What is it normally like? If I look at the past, say, 30 years, what was the temperature like in Nairobi in the middle of next month? That is what we mean when we speak of climate. Average conditions over a sufficiently long period to get a sense of how it can change over time within certain range. The weather refers to short timescales, hours to days. The climate refers to an average over many, many years. It is useful to think of weather and climate as thinking of climate being what you expect, but weather being what you get. In terms of the climate, because there have been signs of changes in climate parameters for a while, for a long while now, for decades, it's important to highlight that there's an important entity, the Intergovernmental Panel on Climate Change, or IPCC. This is a UN-related body. The United Nations, with its many organizations, have decided to conform this intergovernmental panel that convenes thousands of scientists to look at the evidence, to look at what we know about how the atmosphere behaves, how the oceans change, how everything relates to everything else with regards to climate. And every so many years, they publish the IPCC reports, assessment reports that convey the state of knowledge of the science. They always come with a summary for policymakers. So they distill thousands of pages into a much shorter document that is approved line by line by all governments that are part of the UN system. So as you can imagine, this document, the summary for policymakers of the IPCC, is the most respected and most valuable documentation we have to think about the problem and to think about what can we do with regards to it. The main findings of the latest report from the IPCC, which was launched in September 2013, are the following. First, climate change is happening. It's not something that maybe will happen in the future. It is happening now. We see it happening. It is mostly caused by humans. Our own activities are changing the global climate. The global climate will continue to change over the coming decades. How much depends on what we do about it, but the change is pretty much inevitable by now. The rate of change is alarming. It is very concerning to see what is happening. We need to be alert, to continue to monitor, and to take it very seriously. Extreme weather, extreme rainfall, extreme temperatures, extreme winds, these phenomena are getting more frequent. It depends, of course, in what part of the planet you're in. Sandstorms are not going to happen in the South Pole. But in your place, whatever was the usual range of things that happen, it's now likely to go bigger, to go into more unusual, more bizarre manifestations. One of the things we know that the IPCC says, and is very important, it is urgent to stop this change in the climate to the extent possible. We need to do what we can to prevent global climate change from becoming a massive threat, as it may become if we don't take the matter seriously. So you may be wondering as a first question, why is it getting warmer? Why is the climate changing? Well, the short answer is that we humans have been causing most of the change. In the past, there have been natural phenomena, natural reasons for occasional changes in the global climate. There could have been a volcanic eruption that spews all these particles and blocks sunlight, so sunlight goes away, doesn't come in it doesn't warm us and we become temporarily colder. Sometimes there have been variation in the strength of the sunlight, how much solar energy we receive. There have been also natural variations in the chemical composition of the atmosphere, how much carbon dioxide and other gases, and that changes how the sunlight comes in and how much stays with us. In the past, all these things have changed over time, so we have had ice ages, we have had warmer periods because of natural causes. But what we see happening now cannot be explained by natural causes. The science is very clear. Humans have been contributing to the observed change. One of the main reasons for these changes is that we humans are taking stuff from the underground, things like coal, oil, natural gas, these things that have been stored by the planet for thousands and thousands of years. We're extracting them and we're burning them to create energy, to use your cars, your factories, heating your homes. And in doing so, we get some benefit, but we send some new particles up in the atmosphere. Carbon dioxide, especially, CO2, which change the chemical composition of the atmosphere, enhancing what we call the greenhouse effect. I will explain this in a few more slides, but basically this means that the atmosphere is changing. As a result, the planet is changing in how we feel the climate. The most important reason is the burning of fossil fuels. There are a few more reasons, including widespread deforestation. If there's a tree and you chop it down, well, guess what? That tree used to take carbon from the atmosphere. When you cut the down tree, there's no longer this taking from, so more carbon stays up and contributes to climate change. And of course, when you burn the trees, CO2 is released. There's also changing land use. If you use intensive agriculture, that involves a lot of processes that may release greenhouse gases, not only CO2, also additional greenhouse gases like CH4, NO2, and these chemical compounds that, like carbon dioxide, enhance the greenhouse effect. How does it work? Imagine we have the planet, and there's this transparent layer. It's like a blanket. It's a transparent blanket that lets the sunlight come in through the air into our planet's surface. It warms up my head, my garden, my home, the oceans. They all receive sunlight. When this sunlight heats our planet, part of that heat wants to go away, and it remains trapped by the gases in the atmosphere, including CO2. It's good, because if we didn't have the atmosphere, like in the moon, it would be very cold. All the heat that comes in from the sun would go away, and would be freezing on planet Earth. So we like the greenhouse effect. The problem is that because we're extracting carbon and burning it and changing the atmosphere, this greenhouse effect is equivalent to making our blanket a little thicker. So it's still transparent, the sunlight comes in, it heats up things in our planet, but when the heat wants to go away, a larger proportion of the heat stays with us. More energy stays in the Earth's system. That's what we refer to when we say global warming. We can see in this graph that the gases that cause the greenhouse effect, especially CO2, have been changing over time. And this is data from a slide from the IPCC latest report that we just mentioned. You can see in the red line it goes up and down, up and down, up and down, because there are changes in the year. From winter to summer, there's more or less trees. What matters here is that the levels are going up. There's more and more carbon dioxide in our planet's atmosphere. As a result, this blanket that keeps the planet warm is becoming more capable of keeping the planet warm. And guess what? The planet is warming up. What does that mean, that the planet is getting warmer? Well, if you're in Siberia, it may be good news for many days when it was too cold and now it's not as cold. But for the planet as a whole, this can be very dangerous news. First of all, rising temperatures mean that when you get extremely hot days in some countries, you will get extremely hot days. It may be a heat wave, like we saw in the Netherlands and France a few years ago. Above a certain level, the temperature is so hot that it can be very, very bad for fragile people, the elderly, children, people with respiratory problems. Heat waves are more likely to happen, and that is dangerous. These rising temperatures can be problematic. Of course, when temperature goes up, the ice cannot stay in solid form as ice. It can melt down. It can go from the glacier to the river, from the river to the ocean. There is more water in the ocean. Not only that, but the water in the ocean, because it becomes hotter, it expands. We call that thermal expansion. The same water, when it's cold, it occupies a certain volume. When it becomes hotter, it occupies more volume. So more water that occupies more volume, sea level is rising and rising and rising. And that, of course, is trouble if you live in a coastal community or if you're in a small island state. The melting ice has consequences of its own. Rivers that feed on glaciers, for example, they used to be stable in how much flow came down the river. Now, when the ice is melting, there can be more extreme availability of water, or too much water, or too little water. This is a very complicated one. Basically, the oceans are becoming more acidic because these molecules that we're sending up in the atmosphere, they get absorbed by the ocean. And this carbon dioxide and other gases are making the ocean, if you want, taste different in a very, very small way. But it's big enough that the little organisms, the little animals and plants and creatures that live in the ocean, they're very sensitive to it. So coral is not able to grow and stay healthy. Little crustaceans, like shrimp and krill and the like, they need to form their hard shells. They can't do it as well because the water is different and it doesn't let them build at the rate that they were used to. Very importantly, changing rainfall patterns. Let's imagine that this is a very humid place where I am, and where you are is where the winds used to send this humidity. Water evaporates, forms a cloud, and goes to you. And then it rains in your province. That's how it used to be. But maybe now, because of these changing temperatures and changing patterns, the prevailing winds may just change a little bit of direction. What does it mean? It means that the rainfall that used to go to you is now going to the other province. So you get more dry conditions and your neighbors are getting enormous amounts of rain that they've never seen before. This change in space and in time in the seasonality of rain can be very problematic. We also, of course, see changes in extreme events. Not only too much rain, too little rain, too much temperature, as we said, but also in terms of tropical cyclones, snowstorms, hails, extreme winds, many strange things that are happening that are changing in space and in time. It's difficult to say this specific storm was because of climate change. We do not know enough to blame climate change for any one event, but what we see is that the risk of extreme events is changing. I should point out, as the slide shows, that for the first few changes pointed out, rising temperatures, sea level rise, melting ice, and ocean becoming more acidic, the scientists are very sure that this is not only very likely, almost certainly caused by humans, but also like really continuing. This is what we need to prepare to expect. The other two, the changes in rainfall, changes in extreme events, it's less clear because we don't have so reliable data from many parts of the world. And it's more difficult to allocate cause and effect. There's also very clear differences across regions. Maybe your province is experiencing one thing and the province just south of you is experiencing something different. It's difficult for scientists to tell, but we know that strange things are happening and we need to be prepared for those regional changes. Getting into a little bit more detail, it is getting hotter. This graph shows how global temperature on average has been changing over time. We see that some years can be warmer than others. That is natural variation. But we also see this clear trend. It is getting hotter. And this is problematic. The observed change in the surface temperature from the beginning of last century, from the 1900s until now, has been different from one place to the other. But as this graph shows, the trend is clearly for all parts of the world heading towards warmer conditions. Some more than others, and in some places like in the middle of the Sahara, we don't have a thermometer, so we cannot say for sure because no one was looking. That's why it shows in white in some of those pixels. But generally speaking, across the planet, it's getting warmer. And in some cases, even more than 1 degree warmer. That may not sound like much, but think of your body temperature. My body temperature now is maybe 36.8 degrees Celsius or 98 degrees Fahrenheit. If you make me 1.5 degrees hotter, my body temperature, I go from being healthy to having a fever. If you keep me at a fever status for a long while and going up, more and more fever, not good. One important thing to highlight is that our past behavior has already changed the atmosphere. So for the coming years, it will continue to get warmer. For the coming decades even, it will continue to get a little bit warmer globally. And as a result, a little bit crazier locally. No matter what we do now, if we right now stop all these driving cars with burning fuel, all the factories, all the deforestation, if we stopped everything now, our past behavior has changed the atmosphere and the climate will continue to change gradually. Now, if instead of correcting the things that cause climate change, we continue to burn fuel, we continue to drive cars that burn, oil, and the factories that do all these things with coal and so on, well, the changes are going to be so much bigger that the decades, say 30 to 50 to 100 years from now, are going to get much, much worse. It can get much hotter, much crazier. That would be very bad. So we need to address the causes of climate change. We need to change our burning of fossil fuels, land use, all these things, so that for future generations the planet is really inhabitable. Now, even if we do all of that, even if we address the causes, we need to be prepared for some level of change. In this graph, you can see two possible futures that are in the extreme of what we foresee. The blue one is what I portrayed as really changing our behavior, aggressively reducing our emission of greenhouse gases. That shows that it will continue to get warmer. How much, we don't know exactly, but maybe a net total of up to 2 degrees warmer. But if we don't correct our behavior and we keep burning fuel and all these things, it can get much, much hotter, so dangerously that it's a future we do not want to leave to future generations. So the warnings from science are very clear. We really should avoid getting to more than 2 degrees Celsius temperature rise. There's a World Bank report from 2012, Turn Down the Heat, that portrays what would happen if the planet becomes 4 degrees warmer. It's very scary. It's very scary, especially for the most vulnerable sectors of the global population. Subsistence farmers, subsistence fishing villages, people living in the shanty towns. It's so difficult to adapt to such a dramatically changed planet. The more we limit our emissions now, the less need to adapt to crazy futures. The wild weather, we should be prepared for it, but there will be much more if we don't address the causes soon. Back to rainfall details. We should expect change in rainfall. This is showing now, based on what we have seen, there's a range of rainfall in your province, in your district, in your municipality, in your country. If you take that as a baseline and imagine how will it change over the more remote future, the left graph shows how much change to expect if we really reduce aggressively our changing the atmosphere. And you can see that there's bluer. Bluer means a scenario of percent change that shows more change in precipitation of a certain kind, more wet conditions, with some exceptions, like you can see southwestern Africa, for example. Now, all those lines mean that the scientists are not very sure. There's a lot of uncertainty about how exactly it will work. It's important to recognize the weaknesses of science. From science, we can anticipate certain things, but we cannot promise you that that's exactly how the future will be. We see signals telling us that it looks more dangerous. In the graph to the right, you can see that the changes can be much more pronounced if we don't aggressively address the causes. So some parts of the world look much dark blue, that means much wetter. Some other parts of the world look much drier. Again, the uncertainty remains high. We don't know the details. We don't have the crystal ball that tells the future. But our current understanding of the future is enough to tell us that bad things may be coming our way. This is an example from Sri Lanka. You can see the total rain in that line that goes up and down, but in the last years it's been going up and down much more violently. There's been much more extreme rainfall, and this is looking only at the annual cumulative rainfall. But you can see how in the last few decades it's been so much more than in the previous decades, going back a century. You can see the pink line showing how it's looking different. And this, of course, is likely to continue. The long-term average looks scary. There are new record highs. The third question, what does climate change mean for the humanitarian sector? In this module, this is what we really care about. We are humanitarian workers. We see, based on this graph, for example, looking at the past, a very substantial increase in floods, in storms, extreme events that, of course, put a demand on the Red Cross, Red Crescent movement. We see that weather-related disasters have roughly doubled over the past 2 decades. And very interestingly, there's been a very substantial increase in the smaller events. It's not only the big disasters, it's also many small but still important disasters that don't let people, don't let communities regain their strength, regain their well-being, and be able to deal with future bigger shocks. The IPCC report, like many other publications, think of risk as made of 3 components, all of which are changing. One is natural hazards. Too much rain, too little rain, too much wind, that's a hazard. Nothing to do with humans. Those hazards are changing. The number of extreme events associated to natural hazards is looking different. It's increasing. We also have more people in this planet. Population growth, urbanization, etc. means that more people are exposed to these hazards. And finally, vulnerability is increasing. It's not only more people exposed to more natural hazards, it's that some of those people are becoming poorer, are in more fragile states. There are things about our vulnerability to those extreme events that are changing. In some parts it may be getting better, but in many other parts it can be worsening. And this vulnerability, combined with exposure and hazard, means that the risks are increasing. And that, of course, means more work for humanitarian workers. This is one quote from the IPCC Special Report on Extreme Events. You can read, I can read. A changing climate leads to changes in the frequency, intensity, spatial extent, duration, and timing of extreme weather and climate events, and can result in unprecedented extreme weather and climate events. Simple example from my own hometown. I am from Argentina, a city called La Plata, and just about a year ago there was a completely unprecedented rainfall. It rained about 40 centimeters in a few hours. There's no way the city could take that. So about 100 people died officially, plus a lot of people suffering. The wife of my grandmother's butcher had to spend hours with water up to her neck because she couldn't understand what's going on. Where did all this water come from? It had never happened. Unprecedented conditions is what we need to be prepared for. Talking of temperature, when it goes to higher levels, to unusually hot conditions, it can be bad not only for water and glaciers, but also for people and their environment. This map is showing some of the instances where we have had heat waves in North America, in South America, in Australia, very pronounced heat waves. You may recall the heat waves in Europe that led to many people killed in some of the richest countries in our planet. In 2010, we had the heat waves in the Russian Federation that led to more than 50,000 people killed and to forest fires and peat fires. Now, you can imagine that it's not only the air that changes, but when the air is hotter, the forest becomes available fuel for fire. So any little fire under normal conditions would be contained, but now it's really going big. If you have an environment that is conducive to more and more spread. This is important to remember, that changes in one thing can have impacts in others, not only in people, but also in their living environment. The rainy seasons around the world might shift. This is very important for agriculture. Farmers in Southern Africa were used to start planting at a certain time of year, and most years that was okay. But now it can start raining later, can start raining earlier, can start raining like always, but then it stops raining and there's a dry period and the seeds cannot germinate fully. It's getting complicated. The amount of rainfall in each region might change over time. You can have more or less or differently throughout the year, or both, more some years and less some other years. The number of extremely rainy events might increase. This is consistent with both the observed data and the theory that as the planet gets warmer, more of the rain can come in stronger but fewer events. So you can see more dry conditions for a lot of the year and then a lot of rain coming all at once. Changes substantially from one place to the other, but this is a trend that we should be prepared to expect. This, of course, changes not only floods, but also water flows in river, which may become drier some of the time. The same with groundwater. Water stress is expected to be a problem for populations that are already vulnerable and lacking basic infrastructure like water supply. The rainy seasons around the world might shift. This is very important for agriculture. Farmers in Southern Africa were used to start planting at a certain time of year, and most years that was okay. But now it can start raining later, can start raining earlier, can start raining like always, but then it stops raining and there's a dry period and the seeds cannot germinate fully. It's getting complicated. Thinking of your own community, your own work life. What does it mean to have more flooding, different flooding, as one of the potential impacts of climate change? What do you think it would mean for you? Can you individually and collectively, with your team, think about how can we begin to anticipate changing risks and take measures to adapt, take measures to reduce the risk of floods? It is difficult to measure the intensity and the frequency of floods. There are many different ways to do this, but generally we see there has been an increasing trend, and the trend is likely to continue. Of course, rainfall combined with other forces, change in land use, change in population, deforestation, all these things need to be taken into account. More people at risk. What are we going to do? Something can be done. The question is what? The coastal conditions. If you live in a country that has a coast and the sea level is rising, what does it mean? It's not only about water eroding the coast, or when a coastal storm comes, it starts from a higher level so the waves can go deeper inland. There's also the issue of groundwater. Maybe I live on a house that I drill a hole and I have good water to drink, and the sea is over there a few hundred meters away. When the sea level rises, that salt water intrudes into my well, and my drinking water becomes saltier. Water for farming may become unsuitable for the crops. Is this a problem? Can this become a problem in your area? Drought, of course, very severe. Whenever you don't have water, it's difficult for life to sustain itself. Pastoralists, agriculture, urban context, even economic sectors, entire economic sectors, from tourism to food processing, or even industries, even the nuclear power sector may be at risk. Food insecurity is very, very problematic as a threat. We need to anticipate if climate conditions are changing. Are there crop varieties that are more likely to be able to sustain the new conditions? In this image, we see a farmer happily showing cassava, which is drought tolerant. Of course, the nutrition value of cassava may be different from the usual crop. So we need to think of the delicate balance of food production, food processing, storage, nutrition, how to cook. Are people going to be healthy enough to process the food? Do we have the time to teach people, if you're getting more floods, maybe we can switch to rice? But is rice the right thing given what we know? Do we need to train? What is relevant for your place? Disease patterns, this is also crucial. It's not only about the direct impact of, for example, heat waves causing respiratory problems among those with asthma, or flooding causing diarrheal diseases. There's also other things that are a little bit more indirect. For example, mosquitoes. Mosquitoes live in some places and not in others. It can be too cold or it can be too dry. But as the climate changes, mosquitoes are finding good places to live that used to be bad. Mosquitoes can be a little bit of a nuisance, but if the mosquito carries with itself malaria or dengue or many of the other diseases that are vector-borne diseases, entirely new communities can be at risk of diseases that they are not familiar with. They don't even recognize the symptoms. There's one disease now that was familiar in Tanzania and other parts of East Africa called chikungunya. Chikungunya, in the local language Swahili, literally means walking around all bent because it causes pain to the joints. Well, you know what? Now chikungunya has emerged in Haiti. Somehow the mosquito carrying that disease found it suitable to go to the Caribbean. Are we going, as Red Cross, Red Crescent, to help people understand that diseases are changing? And therefore we need to learn to recognize the threat and to learn what to do about it when the symptoms begin to appear, or when we can do something before the bite happens. Can we help people address health risks? The melting ice risk, of course, in mountain areas or in polar regions, there's something that we need to observe more carefully, learn from the science, learn from the local communities that have their own knowledge, their own valuable traditional knowledge, and see how changes in ice cover, changes in ice behavior may be negative, but maybe not so negative if we anticipate them and do something about it. We have seen this image of the glacier. Maybe in your region the changes are different. Maybe they are more subtle. Maybe they are more pronounced. Maybe they have different consequences. What does it mean for you? These changes in ice cover are bad news not only for the glacier itself, that sees its size shrink and maybe even disappear. It's also really bad news for the communities that live downstream and are dependent on the glacier for drinking water. Today, when it rains, water goes down the river, people have water to drink. When it is sunny, no problem. The sun melts some of the ice goes down the river, people have water to drink. And if it snows, okay, it builds up the reserve of water for the future. Now, if because of global warming and climate change, the glacier shrinks and shrinks and shrinks, it means that downstream there may only be water when it rains, and if it doesn't rain, who will provide these communities with water? It may mean more work for the Red Cross and Red Crescent, just as we are already seeing in parts of Kenya and Tanzania, in parts of the Himalayas, in parts of the Andes in the Americas. Ocean changes. We have already mentioned that there's not only sea level rise, more water, thermal expansion, there's also this acidity. There can also be changing storm patterns coming from the coast. The wave behavior, the strength of the waves, the currents. Maybe it affects navigation. Maybe the boats that you used to use for fishing were okay just to row a little sailboat, but now things are changing and you need a motorboat to catch the fish. Maybe the fish are no longer there because it's getting too hot or too acidic, or the food, the little tiny fish are no longer there. Remember also that it's not only climate, it's also other things, for example, pollution. Climate interacts with everything else we do. What does it mean for you? Sea levels are rising, and they're rising faster and faster. We see this is a pretty compelling graph of how the sea level has been changing, but generally upwards, and we see it going up in the coming decades. More about changes in the ocean, the degradation, the loss of ecosystems. Coral reefs are very sophisticated systems where many different creatures, animals and plants, and they find a way to relate to each other and have a healthy balance. When we change a little bit of something, the entire chain may fall apart. The acidification is something that we really are not going to be able to stop by putting a barrier. It's different from, you cannot get drinking water solutions to this. The ocean is so massive, small changes in its chemical composition are dangerous. There has been a lot of news attention to the issue of tropical cyclones. Tropical cyclones, hurricanes, typhoons, they are the same kind of phenomenon. It's a very big storm that takes fuel from hot waters in the tropical oceans and starts spinning and spinning and growing, and it has a lot of damaging power, both in terms of rain and in terms of wind. What's happening with climate change is that there is a very serious possibility that when these tropical cyclones form, they will have more fuel to draw from because of hotter waters. The science is complicated, but we see more intense hurricanes and cyclones and typhoons. And it is quite possible that as the climate change continues to make ocean waters warmer and changing other patterns of the ocean and the atmosphere, maybe when we get a tropical cyclone, it will be catastrophic. We saw recent cases like Hurricane Katrina, like Haiyan in the Philippines, like the many cyclones in the Indian Ocean. Not one of them can be blamed on climate change, but we can tell that as the climate changes, we should expect changes, maybe dangerous changes in tropical cyclones. We should expect economic losses, human losses to increase. What does it mean for the action of the Red Cross and Red Crescent? We need to improve how we manage climate risks. In summary, Because remember, there's more modules in this climate training kit that will give you more detail about climate risk management. But in summary, what should we be thinking of? First, improve our climate risk assessments. Understand what can go wrong. Check how our current programming could be improved, modified to adjust to meet new challenges. Are we doing enough for the risks today? Possibly not. Can we improve it? I'm sure we can. But if the climate is changing, that should give us guidance as to how to assess and how to anticipate. We need more and better disaster preparedness. And this matters at all levels, geographic scales and time scales. One household should be better prepared for flash floods. One community should be better prepared for the threat of a fire. And one country should be better prepared for the threat of changing conditions, be it tomorrow's rainfall or next season's El Niño or long-term climate change. Scientific information can help us make decisions at different timescales. We need to upscale all the many good ideas for community risk reduction activities that are smart. Many different things about water, about health, about food, about homes, shelter. There can be so many things, livelihoods, road safety even. You may be thinking, how can we know what to do to make our communities safer, more resilient, smarter to manage climate risks? That changes a lot from one place to the other. It's in your hands. We need to be more flexible in our programming, including our health programming. We need to be more aware of new things emerging, new patterns of both threats and of possible solutions. And this is an unusual one for us. We need to partner with others who know more. The Red Cross doesn't have enough knowledge about everything. We need to work with those who have technical knowledge, who have community knowledge, who can give us a hand on next steps. To the extent possible, we should also try to influence climate policies. This matters at the global level with the UN climate negotiations, but also in your own country. What is your government doing about the changing climate? Are you seeing national level discussions on policy about land use? Maybe we should avoid the construction of vulnerable homes in the floodplain. Maybe we should provide incentives for people to change their agricultural practices to be more drought tolerant. It changes a lot from one place to the other. The Red Cross and Red Crescent societies usually have good access to government entities. You can take advantage of that if you want to help your own team have less work, because communities can be better off if policy changes. This is an unusual one. Geoengineering. Maybe you've never heard of this. This is an idea to deal with climate change that is like a technological fix. Think of it this way. If the planet is warming up and that is trouble, someone says, well, maybe if I block the sunlight a little bit, just like me, look, if I block the sunlight, I think it's working. No more light coming to me, it becomes slightly cooler. We could put a gigantic umbrella between the sun and the earth, and that will make the planet cool down. Now, a gigantic umbrella is very expensive if you want to block the sunlight from all planet Earth, but we could do, technologically, something similar to what volcanoes do, which is to throw particles up in the upper atmosphere, sulfuric particles, that each one bounces a little bit of sunlight. So less sunlight comes in, less energy warms the planet, it becomes colder. This can be a solution to global warming. The planet would get colder, but we don't know enough about what exactly would happen with rainfall patterns, with temperature trends, with seasonalities. As humanitarian organizations, we see this techno fix as something in the menu of options for those entities making big decisions at the planetary scale. But we have concerns. One concern is who will make the decisions? Will the concerns of the most vulnerable people be taken into account when making decisions on geoengineering? Or will it be dominated by geopolitics or by the concerns of the wealthiest sectors of national economies? Similarly, if geoengineering, which will inevitably be an experiment if ever deployed, it can go wrong, at least in some places, will there be adequate, timely, sufficient humanitarian help to deal with the negative consequences of what some think may be a solution? This is most likely in the very remote future, if at all. But the reason why we include this in this module is to give you a sense of how serious the problem is. Climate change is such a serious problem that in this planet Earth, we're thinking about the deliberate manipulation of the global climate by spewing magic powders in the outer atmosphere to regulate, to manipulate global temperature. That can go right or it can go wrong. If it happens, we need to be prepared for potential humanitarian consequences. There are publications. You can contact the Climate Center if you have questions. Thank you so much for your attention on this first module of the climate training kit about climate science and impacts. If you're interested in further information, here are some resources. The IPCC has a website with all the materials, all the summary for policymakers reports, the long and extensive publications. It's very technical but very comprehensive. You can also visit the climatecenter.org, our own website, with materials that are more suited for the humanitarian sector. And of course, the ifrc.org, the materials from our dear colleagues at the Federation who have developed many, many useful materials. Not only the ones explicitly about climate change, but also many other things like early warning guidelines and so on that integrate climate change into their materials. Thank you so much for your attention and good luck as you think of climate considerations for your work. All the best.